All right, 6.7, the last section in this chapter, is linear systems. Now, we have to take everything we know, creating equations using a graph, a slope, a point, 2 points. All these things are assumed to be known by now. So linear systems just deals with multiple lines at the same time. So if you know how to do one line, if you do it twice, you now know how to do linear systems. So what is a linear system? A linear system is technically two or more equations considered at the same time, but for you guys, it's always going to be two. So I want to consider two lines at the same time, two linear equations actually, two linear equations considered at the same time. Now, if these lines are not parallel, they will 100% cross if they are not parallel. So the point of intersection is the point where these two lines cross. And why are we interested with this? Because this is the solution to a linear system. Okay, a lot of guys are going to be stuck with questions that just say solve and they have two equations. Well, when it says solve and you have two linear equations, this means find the point of intersection. Okay, because this is the solution to a linear system. So if we have to solve, it says find the solution. Solve, solution, same thing. So when you have to find the point of intersection, we know how to graph the two lines. We graph them and we find out where they meet. And you're going to see that in the one example I'm going to do next. It's not too hard. Okay, so in this example, we have to graph these two lines and figure out where they cross, and that's going to be our point of intersection, and then we have to verify, so I'll show you what this means after. Our first job is to graph these two lines. Now you have two skills to graph lines. Slope-intercept form, beautiful, really straightforward. Intercept form, beautiful, really straightforward. If you want to convert this into y-intercept form, or sorry, slope y-intercept form, you can, but I wouldn't because it's one extra step in this case. So first of all, let's graph this line. I have to graph a line using slope-intercept form. I start with the y-intercept, I plot it, and I use slope to find other points. So watch what I do when I'm solving a linear system and I have slope. I'm going up 1 over 2, up 1 over 2, up 1 over 2. I'm not just doing 2 points, I'm doing multiple points, because now when I connect the dots, I'm going to have actual points that fall on my linear system. This looks terrible, by the way. It's because I'm not using graph paper. Okay, but ish, like this, should be a little higher. Now, my next line. So this is this line right here. Let's use pink. I can do this. Y equals negative x plus 6, right? The x comes over, it's negative, the 6 stays positive. And I can do the same strategy. I can go 6 and then over 1, 1 down, over 1, 1 down, okay? Or down 1, over 1, whatever you want with that negative slope. Or I can use the intercepts here. If I hide the x, because it's 0, if I'm using intercept, y equals 6. So my y-intercept is 6. Easy. If I hide the x, if I hide the y, I'm finding my x-intercept. This is easy in this case because there's no coefficients in front of the x and y, and they're both positive. So my x-intercept is actually negative 6 as well. And look what I just did. I drew a point on top of another point I drew. I already know that's the point of intersection. I'm done. I didn't even graph the second line. Okay, so that's why I like to do multiple points using slope for the first line. Because if your second line, your point lands on it, you know you're done. Now if I graph this line, that's a terrible curve. I know you guys are disappointed with me, but it's okay. Okay, therefore, the point of intersection is, what point is this? 6, 0. I graphed this using slope and y-intercept. I graphed this using intercepts. Remember, those are two different sections in chapter 6. Okay, you should know how to graph both ways. If you don't, you can convert it and graph. Okay, so you graph at 6, down 1 over 1, down 1 over 1, down 1 over 1, and you get all the way down here. Okay, but that would have taken longer. Now let's talk about the verification. I want to verify that this is actually true for these two lines. So this is what you do. You write the equation down. Y equals 1 over 2 x minus 3. I'm going to write this one down too. I'm going to plug this x and y into both equations. So this is, the y is 0. 1 over 2 times 6 minus 3. So all I'm doing is plugging in x and y into both these guys. This is a 6, this is a 0, and this is a 6. Now, why am I doing this? Well, I'm going to solve each side independently. So this stays a 0. This is a 3 minus 3. 6 times a half is 3. 0 equals 0. If the left side equals the right side, left side equals right side, I know that it's verified for this line. And now if I know it's verified for this line, I know it's verified for both, therefore it's the point of intersection. So this is 6 plus 0, 6 equals 6. Left side equals right side, therefore 6, 0 is verified. Okay, pretty straightforward to verify, and also straightforward if you know how to graph using both strategies. Okay, so linear systems is no biggie. And that's it for chapter 6. If you have any questions, especially about those word problems, make sure you post them, and I will go through them with a separate video.